Assalamualaikum and very good morning. My name is FIRDAUS Ameen bin Anuwar, and today I'm going to present about my lab 5, which is system response. So for the first part, which is part A, is system response for first order. Basically we need to find our closed loop transfer function for this block diagram. So as you can see here, this is a feedback because of the summing junction are at the back. And you also can see there only one block diagram here, so we can assume that another one is equal to 1. So my calculation would be like this: k, this is for the first block, and 1 is the block below, and I use plus here because of here the polar here is a negative, so we need to use plus. So after I simplify everything, I obtain the last one is equal to 12 over s plus 16. And for the number 2, we just need to insert value into our MATLAB program based on this coding. So by using k equal to 12 a 4, that's why I obtain 12 and 16 here, because I already insert the value. So this is the graph that I obtained from the MATLAB. So you can see here, this is my time constant, and this is my setting time. And for the rise time, I need to minus this one and this one. I insert this inside my calculation. This one, time constant, setting time, and the rise time. So that's all for the part A. And for the part B, which is system response for second order. So given a series circuit here, basically we need to find the transfer function first. And the latest equation I obtained is this: 1 over RCS plus LCS square plus 1. So we need to compare this equation with this general equation for second order, omega n square over s square, this one. So I show my working first. This is how I compare. This is my first equation, and this is my general equation for second order. I compare this omega n square with this one, and 2 zeta omega ns with RCS, because LCS square is for the s square, and also the same for here, omega n square is equal to 1. So when I compare, I obtain another equation where I can find the value of R. So we can find the value of we need to find the value of R here, because the value of capacitor and inductor already given. So to find the value of R for number 3, we just need to insert our damping ratio and our CA capacitor based on my equation this. So for the first condition, I obtain 0, second one 0.4, condition 3 2, and the last condition is 4. This is my working method. And for the last step is the step response for this all the condition. For the first condition, okay, by the way, how I obtain this equation is because from the general equation for the second order. As you can see here, 1 over s squared plus 1, because for the condition 1, you can see here, this is the equation: omega n square, s square, 2 zeta omega ns, and omega n square. The omega n is equal to 1, so this one here 1, and our our damping ratio here is 0, so we cancel out this part. So the only left is 1 over s square here and plus 1. So that's why I obtain this 1 over s square plus 1. So I just insert this this value into my MATLAB, just like I do in my part A, and I obtain the graph like this. So same goes to the condition 2. I only need to insert my omega n value and also my damping ratio, because we have a different damping ratio for all the condition. So it's the same step also here. I insert my my value inside my MATLAB, and this is the graph obtained, and this is the explanation. So same goes for the condition 3, still the same step, and this is the graph and the last condition. I obtained this kind of graph for the last condition. So this is the question and discussion and conclusion. I think that's all for my lab, sir. Thank you, sir.